This is kind of an interesting twist on a revolution of solids. Let's say instead of revolving the x-axis and making the bell go this way, you revolve the y-axis. Let's see what happens when you do that. So when you revolve the y-axis, this shape makes the discs go this way, and you get a shape that looks more like this. So instead of having a horn looking shape, you have more of like a bowl or something. So this makes a different shape, revolving up the y-axis, and you revolve to your bounds will be up and down the y-axis. So notice we're coming up this way. So when we do our integral and our pi and our r squared, when you're revolving up and down the y-axis, you have to count along the y-axis for your bounds. So we won't say from 0 to 2, but rather from 0 to up here to this ordered pair. And you have to kind of figure out, well, what is this ordered pair right here where we stop? See, this graph is bounded right here. Well, if x is 2, this is 2 comma y equals x squared, so 2, 4. Okay, so we'll integrate from 0 to 4 since we're going up and down the y-axis. And the radius is no longer x squared. See, x squared is this dimension. But I want from the axis of revolution to the edge. And so what you have to do is transform this. You have to solve this for x. See, y equals x squared could also be written as x equals the square root of y if you solve this for x. Please square root each side. X equals the square root of y. And if you wanted to write this function in terms of y's instead of in terms of x's, this is how you'd write it. X equals the square root of y. So what I'm going to do is ignore this red part and think of it as x equals the square root of y. So my radius is the square root of y. See, here's x equals 0. Here's the square root of y. Think of it like this. If I'm up here at 4, the square root of 4 is this distance should be 2. And it is. So just to say that again, if I'm up here at 4, and I want to know how far it is to get out to this red dot, well, that distance on the x-axis is the square root of the y distance. So if this y is a 4, the square root of that's a 2. So that's right, this is 2 units. See, 1, 2. Down here, I'm at 0. The square root of 0 is 0. So this is no radius down here. So I'll come over here and I'll integrate, which would be the square root of y squared is just y. This would be dy. And this is a pretty easy integral. This would be pi y squared over 2 from 0 to 4, which is 16 pi over 2 minus 0, which is a pi. So this would be units cubed, whatever my units are. So that's how you integrate when you're going up and down the y-axis instead of left and right across the x-axis.